So, TNT, what is it? TNT actually stands for trinitro toluene. TNT is produced in a three-step process. First, toluene is nitrated with a mixture of sulfuric and nitric acid to produce mononitrotoluene. Sorry. Or in this case, we're going to call it MNT. The MNT is separated and then renitrated into dinitotoluene. Sorry, big words. DNT. In the final step, the DNT nitrated to big words, TNT. There you go. Then an anhydrous mixture of nitric acid and oleum. Then you light the fuse over here, then it goes down, it ignites it's kind of like a blasting cap, but then it ignites that, which sends sparks through all the rest of this area, which ignites all of the TNT, or trinitrotoluene, in here. And then it goes boom. And makes a big hole in whatever you're, blowing up. So, next slide. 2. TNT, trinitrotoluene. Trinitrotoluene is a chemical compound with a formula C6, which is 6 carbons, 2 hydrogens, and I forgot what this one is. I'm pretty sure it's nitrogen. So 2 nitrogens, then 3CH3, so it's carbon and hydrogen, which makes 3. And then, so this yellow solid, because TNT is actually yellow, it's just familiarized in cartoons as red, because normally they put a red paper on the outside of it to hold it all in. So it is occasionally used as a reagent in chemicals synthesis, like chemical synthesis. So synthesis is so. With convenient handling properties, the explosive yield of TNT is considered to be the standard comparative convention of bombs and destructiveness of explosives. So it's like everyone knows TNT, everyone knows that it goes boom, and so it's literally the base model. So that's at the bottom of the list. Things are still below it for sure, like firecrackers and all that. That's way below it, but TNT for all commercial and military grade explosives and everything that falls under that, above that category of TNT, is based off of TNT. That's where it all gets placed. So if it goes boom a little bit more, then it gets placed higher than TNT. Or if it has different classifications or anything. Alright, so classifications. TNT falls under the division 1.1. So there's 6 divisions. All of them have 1 point and then 1, 2, 3, 4, 5, 6. So division 1.1, explosives with a mass explosion hazard. So essentially it just means this explosion only goes boom. Doesn't send shrapnel or anything like a grenade would. It doesn't have like fire or anything. So division 1.2, explosives with severe projection hazard. So essentially what that means is like a fragmentation grenade. That's what that is. It falls under the division 1.2 because it fragments. It spreads out. It's a projectile. Division 1.3, explosives with a fire, blast, or projection hazard, but not a mass explosion hazard. So, okay. So, a Molotov, in this case, or an incendiary grenade, or a phosphorus grenade, they would all fall under division 1.3 because it doesn't explode. It just has a fire, blast, or projectile involved with those. Division 1.4, minor fire or projection hazard, includes ammunition and most consumer fireworks. Okay, so yeah, this is perfect because it involves like firearms. It's the pew-pews. Your pew-pews throw downrange a 1.4 division category. So essentially, so what it means is a fire or spark-driven projectile. So that's where that would fall under. And then Division 1.5, an insensitive substance with a mass explosion hazard. Okay, so it's explosion is similar to 1.1. So essentially, it's just a bigger boom. So essentially, 1.5 would be, in this case, like C4, because it has a bigger explosion than like TNT, but it still isn't. It doesn't have projectiles or fire. And then 1.6 is extremely insensitive articles which do not have a mass explosion hazard. So so essentially this is just like controlled explosions. So it's not that big, but it's not small because it doesn't have a explosion hazard. Okay, so let's move on. So let's move on to 4. So the history. So essentially, it was made by a German chemist in 1863, named Joseph Wilbrand. He was attempting to make like a dye. A different shade of a dye, but he ran into TNT, and he discovered that it was TNT. So it underwent like several changes and stuff, and like experiments by other scientists and chemists and all that. So let's go back to 5 here. Okay, so the impact. The major manufacturing of TNT began in the United States in 1916, beginning of World War I. It was produced in enormous quantities, both commercially and at government ammunition plants for use in military munitions in World War I and World War II. 2006, sorry. During the 1940s through the 1970s, Department of Defense, the DoD, ammunition plants and depots demilitarized off specification unserviceable and obsolete munitions using steam out and melt out processes to recover TNT and TNT containing explosive filters such as composition B, TNT slash hexohydro 135 trinitro 135 trizene, which is an RDX mixture. It's just these processes often generated significant quantities of explosive contaminated wastewaters. The untreated wastewater was discharged into unlined impoundments, lagoons, ditches, and playas, which resulted in significant level of soil and groundwater contamination. From TNT was reported in the late 1980s. And so essentially, it caused bad things to the environment. TNT, it laid the foundation for new technologies and also led to modern controlled explosives including ANFO, ammonium nitrate, and fuel oil, which is more stable than TNT. So essentially, it's a powder. It comes in big, like 50, 100-pound bags, and it's used for mining. It's used for like all these different things, and so it really does like help and increase what that's for. All right, so essentially ANFO is better and replaces sort of TNT. Let's move to slide 7. Buy TNT. Wait for the new generation. IMX 101. The new explosives are a part of a class called Intensive Munitions Explosives, or IMX. IMX 101 packs the same punch as TNT, but it is less dangerous, but has a less dangerous explosive for those handling it. BAE Systems developed the IMX 101 and fielded it in partnership with the Army at Plant Holston, Tennessee. Okay, so essentially the IMX 101 is safer, but it has the same punch. It's essentially, they took it out of a missile, changed it a lot, made it less powerful, less like, oh, I'm gonna kill stuff, and more, I'm gonna use for mining. So it's gonna be coming out, a new generation, in like a year or two. It should come out in like 2022, late 2021, and it will way improve the mining industries and all the industries that actually use the TNT that as we know it today, or trinitrotoluene.